Ever wondered how physics plays a crucial role in the field of medicine? Let's delve into this fascinating cross-disciplinary field, known as medical physics. This is where the principles of physics are applied to diagnose and treat diseases, making it a cornerstone of modern medicine. The inception of medical physics can be traced back to the late 19th century, when Wilhelm Conrad Röntgen, a German physicist, stumbled upon a discovery that would forever change the landscape of medicine and science. In 1895, Röntgen discovered X-rays, a form of electromagnetic radiation. This groundbreaking discovery led him to produce the first ever X-ray photograph, an image of his wife's hand, to be precise. This image, while appearing simple, held immense implications for the future of medical diagnosis and treatment. Röntgen's discovery opened up new doors to a realm where medicine and physics intersect, leading to the development of medical imaging. This includes a range of technologies that allow us to visualize the human body in intricate detail, aiding in the diagnosis, monitoring, and treatment of various medical conditions. These technologies employ a variety of imaging techniques, such as the use of electromagnetic waves in optical imaging, X-rays and magnetic resonance imaging, or MRI thermography, as well as acoustic methods like ultrasound. Medical imaging has come a long way since Röntgen's first X-ray photograph. Today we have sophisticated imaging technologies like MRI, X-ray computed tomography, often referred to as CT scans, and high-frequency ultrasound, all of which have been instrumental in advancing medical diagnosis and treatment. So you see, the principles of physics have been ingeniously harnessed to peer into the human body, detect abnormalities, and devise effective treatment plans. Medical physics has paved the way for non-invasive diagnostic procedures, precise surgical interventions, and targeted therapies. Indeed, the birth of medical physics has revolutionized the way we diagnose and treat diseases. But this is just the tip of the iceberg. As we delve deeper into this field, we'll uncover how the marvels of physics continue to shape the future of medicine. Did you know that the water in your body can help doctors see inside you? This might sound like science fiction, but it's a reality thanks to a technology known as magnetic resonance imaging, or MRI. MRI is a marvel of medical physics, a field that employs the principles of physics for diagnosing and treating medical conditions. One of the key principles MRI uses is magnetic resonance, which is the absorption or emission of electromagnetic radiation by electrons or atomic nuclei when exposed to certain magnetic fields. This principle was first described by Felix Bloch and Edward Purcell in 1946, and later, Paul Lauterbur and Peter Mansfield described how to acquire images from the human body using this principle, paving the way for the MRI we know today. But how does MRI work? The answer lies in the tiny particles called protons. Protons are free hydrogen atoms abundant in our bodies, mainly because our bodies consist mostly of water, which contains 2 hydrogen atoms. These protons, with their net positive charge, act like little magnets, each with a north and a south pole. Here's where things get interesting. When your body is placed inside an MRI scanner, these proton magnets align themselves parallel to the scanner's constant magnetic field. A short pulse of current is then applied, disturbing this alignment and causing the protons to absorb energy from the pulse. When the pulse is turned off, the protons return to their original alignment, releasing the energy they absorbed. Different tissues in the body release different amounts of energy, captured as an electrical current by a special device. This electrical current is then transformed into an image by a computer, creating a detailed map of the tissues inside your body. Because different types of tissue, like gray matter, white matter, and blood, all release different amounts of energy, the resulting image is incredibly detailed. So the next time you undergo an MRI scan, remember you're witnessing a spectacular application of physics in medicine. The water in your body isn't just keeping you alive, it's helping doctors see what's happening inside you. What if we told you that X-rays can provide a virtual tour inside your body? That's right. The realm of medical physics extends beyond the marvels of MRIs. Let's dive into the fascinating world of X-ray computed tomography, commonly known as the CT scan. The principle behind this technology is quite straightforward, yet ingenious. It revolves around the fact that X-rays, as they pass through different parts of a patient's body, are absorbed at varying rates. Imagine your body as a grand, mysterious mansion. Each room, each corner, each piece of furniture absorbs light differently, casting shadows of different intensities. Similarly, in the case of a CT scan, your body's tissues are the rooms, absorbing X-rays and creating what we call a shadowgram. The denser the tissue, the more X-rays it absorbs. Bones, for instance, are quite the X-ray hoarders, absorbing most of the rays and appearing white on the scan. On the other hand, less dense tissues like muscles and organs allow more X-rays to pass through, appearing in varying shades of gray. But how do we get from these shadows to a clear, detailed picture of what's inside? That's where the computed tomography comes into play. As the X-ray tube rotates around the body, it collects hundreds of shadowgram images from various angles. These images are then fed into a computer that uses sophisticated algorithms to assemble them into a three-dimensional view of the body's interior. What's truly remarkable about a CT scan is its ability to provide a detailed peek into the body without any invasive procedures. It can help diagnose a variety of diseases, locate tumors, guide surgical procedures, and even assess injuries with great precision. So the next time you find yourself marveling at the wonders of medical technology, remember that it's all thanks to the principles of physics. Thanks to physics, doctors can now get a detailed three-dimensional view of your body with a CT scan. Can you imagine using sound waves to peek inside the human body? That's exactly what happens in an ultrasound, a marvel of medical physics. Let's dive a bit deeper. Ultrasound, as the name suggests, uses sound waves that are beyond the range of human hearing, typically in the frequency range of 1 to 15 megahertz. But how does it work? Well, it's all about the echoes. When an ultrasound probe, also known as a transducer, is placed on the skin, it sends out a burst of sound waves into the body. As these waves travel, they encounter tissues of different densities. Each change in tissue type causes a bit of the sound wave to bounce back, or echo, towards the probe. It's these echoes that are detected by the transducer and transformed into electrical signals. These electrical signals are then processed by a computer to create an image on the screen. The beauty of this process is that it's real-time, allowing us to visualize the body's interior as it moves and functions. But what makes ultrasound so useful in medicine? For starters, it's non-invasive and doesn't use ionizing radiation, making it safe to use even during pregnancy. It's also versatile, used in many areas of medicine from obstetrics and gynecology to cardiology and musculoskeletal conditions. In obstetrics, for example, ultrasound is used to monitor the development of fetuses in the womb, providing a first glimpse of future generations. In cardiology, it helps visualize the heart in motion, assessing its size, shape, and how well it's pumping blood. Ultrasound is also used in therapeutic applications, such as physiotherapy to promote tissue healing, or in high-intensity focused ultrasound to destroy tumors. In conclusion, ultrasound is a powerful tool in the medical field, allowing us to illuminate the mysteries of our body using the power of sound. It's a testament to how the principles of physics can be harnessed to improve health and save lives. So, the next time you see an ultrasound image, remember, it's the power of sound at work. Did you know that radiation, usually feared for its harmful effects, can actually be used to treat cancer? Let's dive right into the fascinating world of radiation therapy. This technique employs radiation to damage or destroy cancer cells in the body. It's a bit like using a sniper rifle to target enemies in a crowd. The radiation is precisely directed to the cancerous cells, causing minimal harm to the surrounding healthy tissues. You might be wondering, how does radiation destroy cancer cells? Well, when the high-energy particles of radiation collide with the DNA in the cancer cells, it causes significant damage. The cancer cells then struggle to repair this damage and eventually die off. On the other hand, healthy cells are better at repairing themselves, allowing them to survive the radiation therapy. Radiation therapy can be delivered in two main ways, externally or internally. In external beam radiation therapy, A machine directs a beam of radiation to the area of the body where the cancer is located. On the flip side, internal radiation therapy, also known as brachytherapy, involves placing a small radioactive source inside the body, near the cancer cells. It's important to note that radiation therapy isn't a one-size-fits-all solution. The type of radiation used, the dosage, and the treatment frequency all depend on the specific type of cancer, its location, and its stage. The goal is always to maximize the damage to cancer cells while minimizing harm to healthy tissues. Like all treatments, radiation therapy has potential side effects, including fatigue, skin changes, and other symptoms. However, these are usually temporary and can be managed with the help of healthcare professionals. In conclusion, radiation therapy is a potent weapon in our arsenal against cancer. It's a testament to how physics can transform something potentially harmful, like radiation, into a tool for healing. With continuous research and technological advancements, we can hope for even more effective and efficient uses of radiation therapy in the future. Indeed, physics has armed us with potent tools in our fight against cancer. We've journeyed through the fascinating world of medical physics, haven't we? We've seen how physics and medicine intertwine, creating marvels like MRI, leveraging the magnetic properties of water, and CT scans, using X-rays to reveal the body's secrets. And how can we forget ultrasound, using sound waves for diagnosis, or the use of radiation therapy in the fight against cancer? So remember, every time you step into a hospital or a clinic, you're stepping into a world where physics plays a vital role in healing and saving lives.